Hi there, this is Penelope, and this is the third in the video series of vectors for the Level 4 communication, Level 4 science paper for WellTech. Now, we can use the idea of coordinates. We've looked at them before, but now we're going to use them to describe vectors. And we start by introducing a unit vector in the x direction and a unit vector in the y direction, and we call these I and j respectively. Now, for example, here, say we've got a vector from O to P, and suppose P is not xy, but suppose P is 2, 4, then we can say that OP is 2i plus 4j. And what we can do is say that OP, we know this, is equal to OA plus AP. We know that from before. And the magnitude of OA, so the magnitude of OA is 2 units, and we can tell that because it's 2 units there. And it's in the direction of the x-axis. And if we're talking about things in the x-axis, then this is why we use I. So we say that OA equals 2I. Similarly, if we're talking about AP, so AP has a magnitude of 4, and that's come from there, and it's in the y direction, this way. So we talk about that as AP being equal to 4j. Then finally, as we did before, OP equals OA plus AP, then OP equals 2I, that's the OA, plus 4j, that's the AP. And we talk about 2 and 4 as being the Cartesian components of the vector AP. So 2 and 4 are the Cartesian coordinates, and you've done this in maths. Of the vector OP. And we can think about this vector I as being several lengths in several directions, as long as it's horizontal. So this is 1 unit along, this is 2 units along, this is 5 units along, this is 3 units along, but going backwards. Similarly, in the y direction, this is 1 unit up, this is 4 units up, this is 2 units down. So to summarize in more general terms, AB, which is this one, is equal to AC plus CB, so that we can say AB is equal to AI plus BJ. Similarly, if we've just got x's and y's, we can talk about R, if that's its name, as being x times I plus y times j. Let's have a look at some examples. The point 3, 4, for example, would be 3i plus 4j. The point negative 2, 5 would be negative 2i plus 5j. we could represent the point -3, -2, this R3, as being -3i minus or plus -2j, which we could write as -3i minus 2j. This idea of the Cartesian form of vectors is useful if we're adding and subtracting. Suppose we've got a is equal to 7i plus 3j, and b is equal to I minus 2j, and say vector c is equal to -3i plus j, then we can find vector a plus b. It's going to be 7i plus 3j plus I minus 2j, and the net result of that would be 7 and 1 is 8i, and 3j minus 2j would be j. And we could find b plus c plus a, because there's no reason we can't do 3, so it would be 1i minus 2j plus -3i plus j plus 7i plus 3j. And if we collect all those, we would have 5i plus 2j. So we can use this idea of Cartesian coordinates to add and subtract. Previously, in the previous video, we had to use the drawings of them. We can also multiply by a scalar. In this format as well. Remember before we talked about Ka, and it was a and k times longer or shorter. So let's have a look at an example. If we've got v equals 4i plus 3j and w equals -2i plus j, then we can find 2v is simply 2 times 4i plus 3j, which is 8i plus 6j. We could find -3w being -3 times -2i plus j, which would be 6i minus 3j. From the earlier vectors, we can remember about finding the length. So in this case, the length of vector OP, the length of it, and if we call it that, the length of OP, then we can use Pythagoras' theorem to say that OP squared is going to be x squared, because this length is x, plus y squared. So r is going to be the square root of that. So let's just summarize. If r is equal to xi plus yj, then the length of r is going to be the square root of x squared plus y squared. Whoops. Apologies for the slight technical hitch there. Now, let's draw another example. And this time, let's make this starting at 2 and 7 at A and going up to B. And B is the point 4, 11. So that is 4, and that is 2, and A is the point 2, 7. So that's 7, and that's 11. Now, let's find AB. AB, well, let's look at it. AB is going to be, so that's going to be the length across there and the length up there. So AB is going to be this little vector minus vector A. Let's work with a little bit more detail. Let's say that OA is A, and that's the one that we're calling 2, 7, so that would be 2I plus 7J, and let's call OB B, and that's the one that is 4I plus 11J. And we know that OA plus AB is going to be OB. So let's fill in what we know. OA is A, little a, AB is, well, AB, and OB is little b. We need to find this one. So just ordinary algebra. Now we know how to do that. We know that that's going to be 4 plus 11J minus A, and A is 2I plus 7J. So as before, 2I plus 4J. If we needed to find BA, then that's going to be the opposite of AB. So that's going to be the opposite of what we've just found. That's negative 2I minus 4J. If we're wanting to find the length of AB, so we already know that AB is 2I plus 4J, then the length of AB is going to be the square root of 2 squared plus 4 squared, which is square root of 20. We've already seen how a vector can be multiplied by a scalar. We've seen that. So we've got KA. But we need to see a vector multiplied by a vector. And for this, we talk about this as being a scalar product. A scalar product. So if we've got two vectors, oops, wrong colour. We've got two vectors A and B, then the scalar product is defined as the length of A times the length of B times the cosine of the angle in between. So theta is the angle between A and B. So let's look at an example. Suppose A equals 3I plus 2J and B equals 4I minus J. Find A dot B. So it's going to be 3I plus 2J times, dotted with, 4I minus J, which is using FOIL, which you've done in maths. That would be equal to 12I times I minus 3IJ plus 8JI minus 2JJ. And from what you've been taught in class, you'll know that II equals J, and